Shirky's Machine, most entertaining channel you've ever seen. He's always making lots of interesting scenes for you to watch on YouTube.
Welcome back. Or if you're just joining us, in this series we're taking my 1997 Marshall JTM30 dud and turning it into something respectable enough to wear a Craigar nameplate. In the first episode, we concentrated on disassembly and inventorying any salvageable parts. We also got to know more about our series guest star, Craig Barnett of Craigar Electronics. Coming up, Craig uses the schematic to discover what goes where in the stock transformer layouts. And I get the chance to meet the EMB, the amp that becomes the deciding factor in this whole series. But first,
look at the filth. I'm responsible for this filth.
So anyways, if we're going to reuse these, which they're going to get reused whether we use them for you or not, we need to label what we've got here. So I went on Hammond's website to their replacement transformers and looked up what each wire connects to. So this is the output side that goes to your speaker jacks, which I pulled the little panel off here, the little circuit board. So that is what you plug your speakers into. So you can either use an 8 ohm or 16 ohm speaker on this, or you can use the 16 ohm and another 16 ohm extension cabinet. So that's kind of a nice way that they did it. And then they have the direct out. I never tried the direct out. I don't know if you ever did.
I have, yeah.
How did that work?
Absolutely beautifully for clean.
Did it really?
For clean, incredible. Yeah, that's pretty impressive. It's going away, but it's pretty impressive.
It's going away. All right. So I'm pretty confident about this side of about the speaker side of it, and I'm pretty confident I know where everything goes based on where they're winding up on the circuit board. But one way to really confirm it and make sure that my labels are correct, I just set my meter to ohms. So that's my ohm meter, and if I measure between the two that say 6K on them, I'll probably get, like, I don't know, 300 ohms or something like that. Oh no, what? Let's see, what do we got here? So I'm getting about 150 ohms between the two. So I want the center tap to be roughly half of that. And it is 75. So I'm going to take this probe, put it over here, and put this one over here, and I should get 75 on this side too. And I do. So I know, even though the Hammond diagram shows these connectors in a different configuration, I know that since we have the amp powered on and works correctly, that these are the right taps for this transformer. So I can now pull these wires and know where I'm going to be wanting to hook back into when we reuse it, when it gets reused. This one's a little more complicated, the power side, because there's a lot of stuff going on here that's in my way, a lot of it. And I'm not really sure which one is oriented to which, but the power side of it coming out of the wall obviously goes to the power switch. So this is that side of the transformer, which would be the 2, 3, 5, and 6. So that's this side. So if we're looking at the diagram like this, that's how we're looking at it in the chassis. I'm assuming that this would be 2 and 3. So I'm marking those. And then 5 and 6. Okay. So between 2 and 3. So I can use either one of these to hook from the wall voltage, 120 volts, that puts 120 volts on this side, and then on the secondary side is where you get the high voltage, and that's this side here. So let's see, I need to turn it back upside down. So if that's 2, 3, 5, and 6, this is 9, 10, 11, 12, 13, and 14. Alright, so then I want to kind of confirm, based on the schematic drawing, what we've got here. So 9 and 10. Yes, that goes to that big power resistor right there. 13 and 14 we won't be using. That is 25 volts. That would be for your reverb and all the solid state switching and all that stuff, which is right here on the board. And then you've got some relays over here that switch the channel. And then so 11 and 12 are your filament voltage. Wait a minute. So it's 13 and 14. Wow. Okay. I'm just getting a little off here. So 11 and 12 is your filament voltage. Let me just confirm that. Yes, it is. So what I'm going to do, I am going to pull these and power up and make sure that what we've got is what we've got. So this is one of those deals where you want to make sure that you don't want either one of your hands to touch anything inside, because bzz, not fun.
Please don't try any of this at home. You could
Exactly.
die.
So what we're going to do is we're going to connect the power cord back up, and I'm going to measure on no, 13 and 14. Well, we could measure that just to see if that's the 25 volt tap and make sure that I've got it labeled right. That's the critical part. So sometimes it's kind of a little bit of an unknown. Just because the schematic says the red wire goes here doesn't necessarily mean that that's where it goes.
Mm-hmm. Or the table.
So, okay, we'll power it up. Okay, we got our power transformer going, and we're gonna see if that's the 25 volt, which we aren't going to use, but yes, I am. Okay, so unloaded, it's 28 volts right there. All right, so we know that we won't be using those. All right, and then so 11 and 12, I believe, are the 6.3 volt, so that's what we should be getting there. Bzz. All right, steady hand. So, but we know now that that's the tap for the filaments. So I'm going to label that 6.3 volts, and then we know what this is going to be. But we're going to just see what it puts unloaded, what it puts out. And that one I'll need to set to 700 volts. Now a really steady hand for this. Don't want to screw that up. So I'm getting 365 volts on here. Yeah. All right. We're good.
Healthy.
It is. So we'll turn that off so we don't have any kind of problem. We'll unplug that so we don't have a further problem.
Yeah.
They say that don't be deceived by the volts being high. It's the volts that jolt, but it's the mills that kill.
Mm-hmm.
Yep.
Watch those amps, huh?
That's right. This might give us a little bit more of an... Why is that not wanting to come off? Oh, it's got a little nut on there.
On the inside, huh?
Yeah, I don't know
Oh,
if
yeah,
I've
it's
got
tiny.
anything that small. It's very small. I might have a socket that small, but I don't think so. Those. Or Kep's nuts, those work good. Two entrances for 120 volts. Doesn't make any sense to me. 2, 5. It's not gonna, let's see. Goes through the fuse, comes out there. Okay, well here's what we're gonna do. I want to make sure I get this right, so. It's not the first time that's happened.
Oh, yeah.
Well, it's just good that I didn't have both hands in there because if
Oh, it goes across you.
yeah, I would have then you would have been picking me up off the floor.
Oy. Poor Craig. You see the risks involved with all this fun?
Yeah.
If there's any iteration of don't try this at home,
That would be it.
that's the one.
Now the power transformer is isolated from everything else. So what I'm going to do is I'm going to make the assumption here, hopefully rightly so, that it is 2 and 3 that we want to put our 120 volts into, or 6 and 5. But if I get some really crazy reading on these, then I'll know that it's mislabeled on here. I don't know why they would do that. They shouldn't. Well, you didn't want to change your mind and have the JTM back, did you?
You
It's
know,
starting to become too late.
I thought maybe I'd do a quick, no.
I know.
Yeah, no.
You can kind of guess what an amp the power transformer in it was rated at based on what kind of tubes were in it. But if you've got something that's not labeled, there's no tubes in it, and it's like, what went in here? Who knows? So this is my little bench test here. Here's my test power cord. So I just wire nut these on here. Let's see. It doesn't really say which side is common and which side is. Oh, maybe that's what that dot is for. But it doesn't say. So I do want to use 2 and 3, I think.
What's the goal right now with this one?
I just want to make sure that we confirmed what the secondary side, the voltage that comes out of that. And so, oh, I didn't label this one here for the high voltage. I think we got 365 on here. Okay, I just want to confirm that we get the same readings off of pin 2 and 3, and then pin 6 and 5 we will leave unused.
And this is all in an effort to ensure that transformer is a reusable part of this build.
It's reusable for sure. It's just I want to make sure that that's where you put 120 volts on to get the end result on the secondary. So I'll set my meter for volts again and plug this in and try not to shock myself. There we go, 365. Okay, we're all good. And this should be 6.3 volts or 7 or whatever we got before. Yeah. That's what we had before. And then this is the 25 volt one. Okay, so there we are. We have everything properly labeled. Now we can disconnect and not worry about getting shocked.
Nice.
Well, what I will do is put internal and extension labeled on there, so I know which way is which. Why wouldn't I just reuse this too? It's got a fuse in it.
Mm-hmm. It allows the amp to be plugged in modularly too, right? As opposed to hardwired to the, I don't know if that's an advantage in your mind or if that's a disadvantage.
Either way is good. These are just kind of convenient because if you've already got the hole cut in the chassis, you may as well reuse it.
Right.
In fact, I might just have a standalone one that fits in that hole. Let's peel this back. And label it with 2 amp. Goodbye. Though that if you wanted to go the route of the 2 6L6 amp, I'm pretty confident that I would easily be able to build right into this chassis, which is very nice. I mean, it's super sturdy. It's already got all the nuts where it mounts into the cabinet, so that wouldn't have to be all redone, you know, on a rebent chassis. Not a huge deal, but in either event, whether we went with different transformers or these, I think we should keep this. But the only thing that will confirm that is to actually draw out the layout and see how I can shoehorn it in there, which is part of the fun too. But
Yeah. Are those kind of parts things you would want to reuse here?
you could reuse these sockets, and I can kind of show you how I would do it. I usually get the ones not for PCB board, but for regular hand wiring. It has the solder terminals on it, but let's just pull it off of there and see. Arr!
Get out of there!
Now, I'll be able to reuse a lot of this wire, so that'll save us some money too. These as long as we can, because we're not sure how long we're going to need them to be. Printed circuit board, or they wouldn't be.
There it goes.
It takes care of that. Okay, now as far as back to the sockets, we talked about that. Oh, look at, I'm making a mess. Strip down to pretty much the last stuff that will be able to be reused. The front panel switches, those can be reused for power and standby. The output and power transformer can be reused. And then we have our power board right here that has the fuse already all mounted to it, so all you got to do is, you know, screw it back on here. And then we also have our output jack board, which I put somewhere. Oh, right here. It's still, there we go. Okay, so we'll keep that. This other stuff goes away. I will take all of this wire off of here and reuse it. Stuff like this, probably not, because it's just real short.
Yeah.
But, so, as you can see, here's how these, some cutters over here. here's how these mount to the board. And they've put a nice little space between the actual board and the connectors so as to keep the heat from the tubes away from the traces. I've seen these on ones that are mounted like this, right?
Yeah.
And you've got your power tubes that are generating an awful lot of heat, and what winds up happening is this part of the board just gets burned.
Ah.
And then pretty soon your little pads where which is the mechanical thing that's making the connection,
Yeah.
will crack.
Aye.
And when they crack, then what you wind up with is intermittent connections, short problems. Why do I keep ruining tubes?
Yeah.
Well, hello, there it is right there. So, but what I've done before with these is to just snip them off like so. And probably the nicer way to do it would be to just unsolder them, but this works good just for the demo purpose. So they're still nice sockets, but what do we do in order to make something that you can solder to, right? You can drill a little tiny hole down at the bottom right there, which I probably would do. It's nice to have a couple of places on these to make the connection,
Yeah.
but what you do is you just take your little deals here and you make like a little loop, and voila.
Hook your.
You just stick the wire in there, solder it in, and it's just every bit as good as the regular sockets that have the soldering pads on them, or terminals, I guess you'd call them. But yeah, so there. Repurposing, I kind of like it,
Yeah.
and I'm not throwing everything away. I'm getting the reused stuff that probably would get thrown in the garbage for anyone that was doing a flip. I don't know that I've actually seen anybody else do this. I'm not saying that they don't.
But you can't think of any good reason why you wouldn't.
No, because it basically gives you everything that you've got on the other socket that's intended for hand wiring. You've got a nice spot to connect your wire into, and then you've also got a little spot right here where you can drill a hole so you can get another wire in there, because some of them require a couple of connections. I don't see any reason why these wouldn't work fine. But you can see how the preamp tubes, they don't generate a ton of heat, so it's really not critical that they be telescoped off of the board. Even if it is turned like this, it's fine with them generating the heat up into it. Generally speaking, you don't see those get burned. I like to use Teflon coated silver wire. It's stranded, and the jacket is really nice because it doesn't burn. So if you're coming in on an angle like this to a connection, and you've got regular PVC coating on there, so you've got your little stripped end right here that you're going to solder on, and you've got a real tight bend that you need to make, like say like that. What'll happen is when you get the heat of the soldering iron and the solder flows, when it's that hot, this will separate off, and then you've got like the jacket is melting off of it. So this stuff's super nice. It does not melt.
Are you still with me? I know I said I'd meet the EMB. What I didn't say was, you'd have to wait until the next episode to meet the EMB. But I promise you it'll be worth the wait. We also make the final decisions on the component layout and prep the chassis for what will possibly be my new go-to sidekick for BSV. We'll see you next time. Thanks for watching.
Shirky's Machine, most entertaining channel you've ever seen. He's always making lots of interesting scenes for you to watch on YouTube.